In today's episode, you'll be introduced to the basics of creating your own model in machine learning. We'll go through the steps of creating a model as well as visualizing it, because you've been waiting long enough. Machine learning has become an integral part of data analysis, and in today's episode I want to break it down a step further, as in this mini-series of machine learning I've been breaking it down into sizable chunks. Welcome back, guys, to another episode of PyPod Chronicles. Welcome to PyPod Chronicles, a series that brings our tech blog to life in a whole new way. Covering an array of topics surrounding Python and tech, from programming tips, best practices, and so much more. Let's get immersed in Python with the Nerd Nook on the go. Before I dive into today's episode, guys, the link in the description, wow, the value packed into that. You can get a free 13-hour Python course. You can get all my free newsletters and the resources I have available to you guys. Jam-packed with value. Head on down there, check out what I have, use it to help you in your Python journey. Alright, so today we're going to address choosing a model in machine learning, right? Because last episode I kind of went through, the three overall topics, right? Regression, classification, clustering. And today I want to create a model around one of those. And specifically that model, I want it to be a simple regression. I just want to enter with regression, right? That's the easiest one to just kind of comprehend, I feel like. And it's a great starting point. Now, regression in machine learning is like the art of predicting the future, right? So however you want to view that, it really is, because we're using patterns from the past to try and make a future prediction. Now imagine you're trying to predict the price of a house. You gather data on various details that could affect the price of the house, like the size, location, how many bedrooms, right? All of this, it's going to affect the overall price of that house. And our regression algorithms can analyze these features, these input variables, and then build a mathematical model that can predict the price of a new house. It's like being able to use that historical data to forecast our outcomes. But here's where it gets really exciting, because regression isn't just about houses. It's about understanding relationships. Josh, what the hell do you mean? Well, we gather clues, we gather data to try and uncover connections between them. And with regression, we're not just predicting housing prices. You could forecast stock prices, analyze your customer behavior, or even predict the outcome of sports games. Although that's not me encouraging gambling. The possibilities are endless. Before we dive into the ins and outs of linear regression, because we have logistic regression, linear regression as the two selling points here, I want to focus on linear. It's crucial to have a clean data set. Now, those are previous episodes. You can go back to that when I addressed with Pandas about how we can clean our data. Go back to the machine learning episode with data pre-processing. I also addressed that. That's the link in the description. Now, let's just assume that we have clean data. And we've done that with Pandas. So I'm going to assume that I have a data set called cleaned data, already ready to go. Once we have our clean data, it's been pre-processed, okay, it's time to split that data into your training and testing sets. So remember from the episode I introduced train, test, split. We can give it our X and Y, and then that's going to output our 4 training and test sets. Well, 2 sets, right? 4 values. X train, X test, Y train, Y test. So we have these returned values now from train, test, split. It's now time to create a linear regression model. Now, linear regression is a supervised learning algorithm that we can use to predict continuous outcome variables based on one or more predictor values, or variables, Now in Python, we most likely are going to use something called Scikit-Learn or sklearn, right? That's just seems to be the most popular one and the one that I've been teaching, using for machine learning. An easy way to remember this is stock prices. Is it going up? Is it going down? Just these basic analogies help me remember these faster. We have those 4 return values from train, test, split. I'm going to now create an object, okay? So I'm going to import from sklearn, tap into linear model, import linear regression. Now I'm going to create an object called model. That's going to be our linear regression class. I'm going to take my object and I'm going to apply the method fit. We give fit 2 arguments. This is our training data. It's 20% of the total supply. So X train and Y train. Okay, now remember from my analogy in the episode of Train Test Split, think of these as a set of flashcards. X train is a picture, like a picture of a chicken. Y train is the answer. It's like the word chicken, okay? So the computer can see the train set. It can't see the test set. So really now that you've applied fit, that's really putting your training set in the model. You can just use a prediction, right? I'm going to create a response prediction, okay? And then I'm going to take my model and link the method predict. Only give it X test because it can't see the Y test. Now that we have this variable predictions, that is the predictions that the computer has made for my data. We need to visualize this data, all right? What have I talked about in the past? Matplotlib, right? You can use Plotly, all right? But scientific purposes, right? It's just easier to get started with Matplotlib. If you're going to do a really big project, once you get it working with Matplotlib, you can just transfer it over into Plotly. All right, so we import matplotlib, and I'm going to use what I get back predictions, and I'm going to plot that. So what I could do here, right, is I could create a scatter plot, all right? And initially, I could plot my test data set, so the X and the Y test. Then I could create a plot. So I have like 2 different ones. I'm putting a plot in my scatter plot, and this plot is going to be a line to see how accurately the computer predicted. So it's like how close are all those scattered dots to our line, and can we see any type of regression, right? Are we going up? Are we going down? That's a very straightforward way that we can plot those predictions. Now that you've plotted these, you gotta fine-tune your data like your dad's acoustic guitar. Right? So fine-tuning your linear regression model is what makes your model better than everyone else's. Don't stop when you're done. It's about fine-tuning. It's just those small extra additional steps. So like imagine an untuned guitar. Does the guitar work? Literally, yes. Does it sound good? No. Sounds awful. Right? The same idea applies there. So begin by scrutinizing your model's hyperparameters. That's like the dial and knobs that change your model's behavior. As you explore deeper, consider employing cross-validation techniques to ensure your model's robustness across diverse data sets. All right, so, you constantly just want to be tweaking it. And as it goes on, improve it, right? Because that's what keeps your model up to date and more accurate. So very quickly, of real-world application. Okay, let's give this to just make sense of everything here. Linear regression serves as a cornerstone in various domains. Take finance. Everyone loves finance, where predicting stock prices is like navigating a hurricane or navigating through a hurricane, right? Every day the market is changing. Before computers, people were just guessing prices. I'm kind of joking, right? But not really, right? How did we predict those before? With previous data. Still, we just use that. Now, using linear regression, you can model historical price trends against factors like economic indicators or company performance metrics to forecast future movements. By identifying these correlations and patterns within your data, the Wall Street suits can make informed investment decisions, mitigating risks and maximizing returns in an ever-changing landscape. But let's not forget 2008. And once again, I would like to say thank you to the Lehman Brothers for being a big player in that. All right. Conclusions. Let's wrap it up here, guys. Master and learn linear regression in Python to help your data analysis skills. This is going to help you make accurate predictions. Our enhanced code and visualization techniques provide a deeper understanding of the process. Now, a few questions, right? In case you missed anything or you were too busy, doing something else, right? Linear regression differs from other models because linear regression focuses on predicting numerical outcomes based on a linear relationship between variables. And the one thing we don't want to use linear regression for is time series data. So it's effective for a lot of tasks, but with time series data, time-dependent relationships often require specialized models. So make sure you have clean data, right? That's key. And lastly, guys, I'll just leave you with this. I've only scratched the surface here. In the coming episodes, I would like to explore other models and implement those. Most of my content is to help you guys, to help people comprehend and understand advanced topics on a deeper level. I know it's hard, guys. Stick with it. Practice. I'm only trying to make it easier. If you guys got value from today's episode, do me a favor, hit the like button on whatever platform you're on, drop me a comment, share this with your friends, head to the link in the description. All this content is brought to you free. Well, guys, that's another episode of PyPod Chronicles. Cannot wait until next week's episode. I will see you then.